Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given the Laplace transform of the voltage across the capacitor. And this Laplace transform can be given by this expression. So here, the value of the capacitor is equal to 1 by 2 Faraday. And we have been given that the initial voltage across the capacitor is equal to 0 volt. So here we have been asked to find the value of the current through the capacitor at time t is equal to 0 plus. That means here this is the expression of the Laplace transform for the voltage across the capacitor. So in the denominator, further it can be written as this s square plus 1 times this s plus 1. That means in the numerator and the denominator, this s plus 1 will get cancelled out. And this Vc of s can be given as 1 divided by this s square plus 1. So we know that the capacitor current IC can be given as C times this dV divided by dt. So let's say in the Laplace domain, this current IC of t is equal to IC of s. And using the differentiation property of the Laplace transform, this dV by dt can be written as this s times Vc of s minus Vc of 0. So here for the capacitor, this Vc of 0 is equal to 0. That means this current IC of s is equal to Cs times Vc of s. And here the value of C is equal to 1 by 2 Faraday. That means this current IC of s is equal to 1 by 2 times this s times Vc of s. And here the value of Vc of s is equal to 1 divided by this s square plus 1. So we can say that this current IC of s is equal to s divided by this 2 times this s square plus 1. So here we have been asked to find the initial value of the current through the capacitor. So in the Laplace domain, we can find that with the help of the initial value theorem. So we know that as per the initial value theorem, as the limit t tends to 0, this IC of t can be given as limit s tends to infinity, this s times IC of s. And here this IC of s is equal to 1 by 2 times this s divided by this s square plus 1. That means here we will have this limit s tends to infinity, this 1 by 2 times this s square divided by this s square plus 1. So now if we divide both numerator and the denominator by s square, then further we can write it as limit s tends to infinity, this 1 by 2 times this 1 divided by this 1 plus this 1 divided by s square. Now in this expression, as the limit s tends to infinity, then this 1 divided by s square will get 0. And we will have this 1 by 2 times this 1 divided by 1 plus 0, or that is equal to 1 by 2. So we can say that the capacitor current IC of t at time t is equal to 0 plus is equal to 1 by 2 ampere. And therefore, for the given question, this is the correct answer.